In the previous video, we looked at how to symbolize your LiDAR to start to pick out some of the interesting features in the landscape. In this video, we're going to start deriving a number of data sets that should help you even more with that. So the first thing that we're going to do is to use the fill tool in Spatial Analyst. So fill, as the name suggests, fills in all of the depressions in your landscape, and that gives you a raster that you can then run the flow direction and the flow accumulation tools on. So you're creating a surface that isn't necessarily as accurate as your original DTM, but it means that you can create usable data sets that show you where flow accumulation is. So you can input your DTM here and call it fill. You can specify the Z limit here if you didn't want to fill all of your sinks. But in order for us to proceed with the flow direction and flow accumulation tools, we need to know that there aren't any sinks in the data at all. So we'll leave that as the default and run it. Okay, so this should be fairly similar to original DTM, but without any sinks, so that we know that when we start to look at flow accumulation, it's not going to disappear into a hole. So we can take that off for the moment. And the next tool that we need to run is flow direction. So if you input your fill DTM, I'll just show you here. This creates an output that shows where water is moving from one cell to another. And we need this to be able to create our next data set, which is flow accumulation. So we can leave the defaults as they are and run the flow direction. Okay, so this starts to look a little bit interesting, but don't worry about it, because we're just going to be using this data about which direction each cell moves in, and that's going to allow us to build a map of where flow accumulates in the catchment. So our next tool is flow accumulation. As you can see here, it's asking us to input our flow direction raster that we just made, and we want it to be flow accumulation, and again we can leave the defaults as they are. The output that you get for flow accumulation that you'll see in a minute is most of the catchment will look black, and so we need to do an additional step to help you pick out the areas where flow accumulation is highest. So as you can see, most of the catchment we can't really see any detail, and it looks like we're starting to pick up some higher accumulation around here, but it's not terribly useful in that format. So what you can do is to use the Raster Calculator to pick out the cells in this raster that are greater than a particular value. So we're only interested in areas where we've got lots of other cells flowing into them, so they've got a higher accumulation. We're not interested in the cells that don't have much accumulation because they're very likely not to be streams or overland flow. So you can use a conditional statement in the Raster Calculator. You put in con and then your flow accumulation. So we're saying if the flow accumulation value is greater than 500, then we want to keep it. And if not, we don't. That's essentially what this statement is saying. This value here, 500, is quite arbitrary. Well, it's very arbitrary. That just means the number of cells that flow into the cell that we want to keep. So we'll run it with 500 and we'll see what the output looks like, but you can increase or decrease this number to get it to an output that you're happy with. So we'll call it something like flow accumulation greater than 500. We'll run that tool. Okay, so we can't see it because it's on top of the other one, but if we remove this bottom one and we'll zoom in, you can start to see that it's picking up the network of channels. So we've got, just follow it down, we've got lots of small channels coming in, and as the value increases, like the flow accumulation increases, then it turns lighter and lighter. We can go ahead and change this number just to show you what it looks like. So if we say that we want 1,000 cells to be flowing into the output before it displays, we should see fewer channels because we're looking for a greater amount of accumulation before it displays. Yeah, so this one's got much less detail, which is probably more appropriate, and load. This is still picking up probably a lot of the overland flow in addition to the main river channels. In the next video, we will look at how you can compare these flow accumulation maps to some other data sets to help you to identify things like paleo channels. Thanks very much.